Hello, this is Mr. Henry, and welcome to lesson 5.4. Today we are looking at writing equations in standard form. So the essential question is, how do I write equations in standard form? For the get to goof, all I want you to do is try to identify which equation looks like which form. So far we've talked about point-slope form, we've talked about slope-intercept form. We have not talked about standard. So see if you can match up each equation with which form it looks like. So we've done slope-intercept. That's the one we've done a lot of. And this is slope-intercept. Slope-intercept looks like y equals mx plus b. We've seen point-slope, that one. Point-slope looks like y minus y1 equals m times x minus x1. The one we have not seen yet is standard. And actually, we did see it a while back. We just didn't call it standard form at the time. And this looks like ax plus by equals c. Now, one thing I want you to notice about this standard form is that there is no m. The m is what we have for slope. There is no m. So just by looking at this, you do not have a slope. You do not have an intercept. You do not have a point. So this standard form is, you cannot graph directly from this. You actually have to change this into one of the other forms if you want to graph. But we'll see that as we go through the lesson. So the vocab today is standard form. Probably could have guessed that. And we've already seen what it looks like. ax plus by equals c, where a, b, and c are real numbers. So that's pretty much any number you can think of. Positives, negatives, decimals, fractions, even weird numbers like pi, those kind of things. And it says a and b are both not 0. So you cannot have a standard form that's just 3y equals 5, because you'd have 0x. So you cannot have this equal to 0. This is not standard form. Both the a and the b have to be numbers. But you could have, say, 3x plus 9y equals 0. This guy is allowed to be 0. Okay? So the first thing we're going to do is says write two equations in standard form that are equivalent to, and it gives us the expression or the equation, 3x plus 4y equals 7. Well, here's what I would do. We're going to take this entire equation, and I'm going to multiply everything. This guy, this guy, this guy, everything, both sides, multiply by 2. Let's see what we get. We would get 6x plus 8y equals 14. That is an example of an equation. This is exactly the same as that. All we did is we multiplied both sides by 2. And as long as you do a math to both sides, it's correct. I could, if I wanted to, divide both sides by something here. So let's try that out. Let's see what happens if we divide both sides by 2. So if you need to take out your calculator to do the divide, so 3 divided by 2, it's going to give you 1.5. So you can say 1.5x plus 4 divided by 2 is 2y equals 7 divided by 2. If you need your calculator, it's 3.5. This is another example of something that's equivalent to this. We divided everything by 2. Everything on both sides by 2. Now, it doesn't always have to be by 2. I could have here taken this and multiplied by 3, or multiplied by 5, or divided by 19. As long as you do the same thing to both sides, it's still equivalent to the original equation. Okay, let's see another example here. Instead of taking times by 2, I'm going to take this guy times by 3, just because. So 2x times 3 gives me 6x plus y. Well, how many y's are there? If you don't see a number in front, it means there's one of them. So 1 times 3 gives me 3y, and equals, and 6 times 3 is 18. So I took everything times by 3. How about for the side over here, we're going to take everything times by, let's pick a number, say 5. I don't know. Let's pick something. So 2 times 5 is 10x. 1 times 5 is 5y. And 6 times 5 is 30. So this guy, and that guy are all similar equations. They're all equivalent. It's almost like how fractions, if you have 1/2 and 3/6, how those two are equivalent. All we do here in this is we took this guy times by 3, this guy times by 3, and these two fractions both equal 1/2. Well, it's the same deal here. I took everything here times by 3 to get this. If we divided everything by 3, we'd get back to that. Same deal. So these are equivalent expressions, equivalent equations. Now for letter C, here's what I want you to do. I want you to first start by making up your own equation. So come up with some equation. So something x plus something y equals something. Put your own numbers in there. And then come up with two other equations that are equivalent to that. Take a minute or two, pause the video, do them on your own. When you're ready to continue, hit play and we'll go through it together. Okay, so here's one I'm going to come up with off the top of my head. I'm going to pick negative 5x plus 4y equals negative 14. Why not? Some big numbers, I don't care. So first off, to get this equation, I'm going to take all this stuff and I'm going to multiply it by 2. I'm going to get a negative 10x plus 8y equals a negative 28. That times 2, that times 2, that times 2. Now for this side, I'm going to take everything times by a negative 3. So that's going to give me a positive 15x plus a negative, so plus a negative is really just a minus 12y. And 14 times 3 is 42. That gives me a positive 42. I could have taken everything here and divided by something. I could have taken it divided by 2, for example, and I'd get a negative 2.5x, that's a point in there, plus 2y equals negative 7 would work. I could have taken everything here and divided by 7 if I really wanted to, and I'd have to dig out the calculator to get some ugly decimals. But it really doesn't matter what you multiply or divide by, as long as you do the same thing to every term on both sides. Okay? Now, we're going to see how to write a standard form equation from a graph. So here I have 2 points, and I want to be able to write the equation in standard form of the line that passes through those points. So let me draw this line for a second here. Do 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 do. I guess it's kind of like that-ish. Yeah, something like that. That's pretty close. Alright, so I want the equation of this line in standard form. So the first thing we do is I look at that and I go, well, you can't go straight from that equation into standard form. But what we can do is we could write the equation of that line in, say, slope-intercept form or point-slope form, and then change it into standard form. Well, Since here on our graph we have points, probably the best thing to do is find our point slope form, because we don't have a y-intercept. So first off, to get point slope form from 2 points, we need to be able to find the slope and a point. So let's see, slope. Well, this point is at 1, 1. This point is at 1, 2, negative 2. So x value, y value, this is 0.1. X value, y value, this is 0.2. Remember all this stuff? To find slope, it's y2 minus y1 over x2 minus x1. That gives me negative 2 minus 1 over 2 minus 1. Negative 3 over 1, which is just negative 3. So I have slope. The slope of this line is negative 3. Okay? Do I have a point on the line? Well, yeah, I've got 2 of them. I've got this point here I could use, or this point here. I'll be honest, I'm going to use this one because it's 1, 1. Those points are easy. So if you remember point slope form, it looks like y minus y1 equals mx minus x1. Okay, so all we do now is we plug in the point and the slope. So y minus, what's the y value? 1. Slope x minus the x value, 1. Okay, so far? So we wrote the equation of this line in point slope form because we were able to find the slope from 2 points and we had a point. Now what we want to be able to do is we want to take this and change it into standard form. And what we mean by that is we're going to take this equation, so I'm going to write it down again. Oopsie, it's supposed to be a 1. We want to take this equation, and in the end, we want to have something x, something y equals something. So we want all of our x and y values over here, and everything without an x and a y on the right-hand side. So let's do this. So we look at our equation, and we want to solve. We're going to use those same 5 solving steps we did before. First things first, get rid of them parentheses by distributing. So I'm going to distribute here. This gives me negative 3x plus 3. Okay, parentheses are gone. Remember our goal. We want to get the x value and the y value on the left. We want everything that does not have an x or y value on the right. There. So we want the stuff I've underlined in blue on this side, the stuff I've underlined in red on this side. Well, let's get rid of this. Let's move the x to the other side first. So the way we get rid of an x on this side, this is a negative 3x, is we add 3x, because a negative 3x and a positive 3x equal 0. But you have to do it to both sides. When you add 3x here, what do we get? Well, let's see if we move this down. There we go. If we rewrite what we have a 3x, a positive y, minus 1 equals, this is gone, 3. We're almost there. We have the x's and y's on one side. The only thing we need to do is get both of these red guys on the right-hand side. Well, he's already on the right, so we just have to get rid of this minus 1. So if I add 1 here, it goes to 0. Add 1 here, and what do we get? Well, we get 3x plus y equals 3 plus 1 is 4. This is standard form. We have our x's and y values on the left. We have everything else on the right. This is what standard form looks like. So to recap the whole problem, in case you missed any of it, I'm going to walk through one more time. We had 2 points. From those 2 points, we were able to find the slope of that line. We did y2 minus y1 over x2 minus x1, did the math. We found the slope was -3. Then, we used that slope and one of our points, I used this guy, and one of our points to write the equation in point-slope form. Plugged in the y value for y1, the x value for x1, and the slope. Looks like a sad guy. He's not too happy. Then we took this equation, rewrote it, and then we took it and transformed it into standard form by just moving pieces from one side to the other. So we first got rid of the parentheses. Then we wanted the x not to be on this left-hand side. I'm sorry, on the right-hand side. So we got rid of it, and it came to the other side. We did not want this -1 on the left-hand side, so we added 1 to both sides to get rid of it here, and added it to the other side, and now we have all x's and y's on one side, everything else on the other. That is standard form. Okay? Sounds like a lot of work. It's really not that bad once you get the feel for it. Let's see another example here. So, same deal. Write the equation in standard form of the line that passes through the given point. So we want standard form, which means we want ax plus by equals c. So first things first, I'm not going to draw the line in here this time. So let's see. We want the slope of these 2 points. So this is the point 1, 2, 1, 2, 2, 2. This is the point 1, 2, 3, 4x, -2 and y. X value, y value, we'll call this point 1. X value, y value, we'll call this point 2. So to find the slope, we take y2 minus y1 over x2 minus x1. So up top, we get a -4. Down below, we get a 2. This simplified, -4 divided by 2 is -2. That's the slope. Now we've got points. We got 2 points here. I'm going to pick this one to use because both numbers are positive, and why not? It's easy. So we're going to use the point-slope form of y minus y1 equals mx minus x1. So y minus the y value equals the slope x minus the x value. So we're like halfway there. What we have to do now is we have an equation in standard form. We want to be able to take this and write it into, we have an equation in point slope form. We want to write it into standard. So I'm going to rewrite it. Y minus 2 equals -2, x minus 2. Alright. So standard form. We want x's and y's here. We want everything else over there. So first thing first, get rid of them parentheses. We get -2x plus 4 okay, so we want this x not on this side, we want it on the other side. So we're going to add 2x here to get rid of him, add 2x there. That gives us, well, what do we have on this side? Write it all out. We've got a 2x, we have a positive y, we have a -2. This is gone, so on this side we just have this 4 left. Okay, so we have x's and y's on this side. We want everything else over here, which means this guy has got to go. So the way we get rid of a negative 2 is we add 2. Add 2. These cancel. So write it all out. What do we have? Well, we have 2x plus y, he's gone, equals 4 plus 2 is 6. And that's standard form. We have all the x's and y's on one side, everything else on the other side. That is standard form. So that's how we do it. That's probably the simplest method of doing it. There are other methods you could take from the 2 points using some of those other methods we did. You could find this in slope-intercept form and then change it into standard form. It works, but it's a little bit more work to do. Letter C. Here's what I'd like you to do. In this problem, I don't give you a picture. You have the word problem, and it just gives you the 2 points. So what I'd like you to do is do the same problem, find out what the equation of this line is in standard form using just those 2 points. So you're still going to find the slope. You're still going to write the equation in point-slope form. You're then going to change it into standard form. Pause the video. Do that now. When you need some help, you get stuck, or you are done, and you want to make sure you did it correct, hit play, and we'll go through it together. Okay. Let's see how you did. Hopefully you were able to go through the entire problem without too much trouble. So let's see. We have 2 points. How does green show up? Oh, not bad. All right, we'll use green here. So we have ourselves 2 points here, and we want to write this in standard form. So the way we did it before is we found slope, we found point-slope form, and then changed it into standard form. So that's our checklist. So first thing we need to do is we need to find the slope of these 2 points. So we've got xy of point 1, xy of point 2. Slope is y2 minus y1 over x2 minus x1, giving us negative 5 over 5 simplifies to negative 1. So we've got ourselves a slope of negative 1. Okay, so we got slope. Then we write this as point-slope form. So using one of my points and the slope, we put it into that y minus y1 equals mx minus x1 form. Well, this one, both numbers are positive, so I'm going to use that one. I think it's just going to be easier. So y minus the y value, negative 1x minus the x value. So point-slope form, done. Last thing we have to do is we have to change this into standard form. So we're going to get the x's and y's on one side, everything else on the other. So we're going to distribute. This gives us a negative 1x plus 1. Get the x's and y's on one side. So we're going to get rid of this. We're going to add x, well, I guess it's a 1x. We could do it that way. I'm going to shift it this way a little bit. So we get 1x plus our y minus 4 equals, let's see, this cancels out, so we have just 1 left. So we got x's and y's on one side. Good. We need everything else on the other, which means we need this piece gone. So we're going to add 4, add 4. So we get 1x plus y equals 5. That is our standard form. So we found the slope. We wrote the equation of that line in one of the forms we knew, point-slope form in this case, and then we changed it into standard form. If that did not make sense to you, I'd recommend going back and watching one of the first 2 examples again. Now that you have the notes, really pay attention to it and hopefully it'll make a bit more sense to you. Okay, moving on. I'd like you to try these two problems from the textbook, page 311, numbers 1 and 2. It's the same deal we've been doing. So go ahead, try that out, pause the video, do it on your own, do as much as you can. When you're ready to continue, hit play, and we'll go through it together. Okay, number 1. We want to write two equations that are equivalent to this. So I'm going to take everything here, and I'm going to take it times by 2, and then I'm going to take it times by -4, just because. So times by 2 gives us a 2x minus 2y equals 6. That's times by 2. There's 1x here, took it times by 2. There's 1y there, took it times by 2. Now I'm going to take everything and times by a -4. So I'm going to get a -4x. A -1 times -4 is a positive 4y. And 3 times -4 is -12. There we go. These are both equivalent to that. There's number 1. Number 2. This is the hard stuff we were just doing. Write an equation in standard form of the line going through those 2 points. So remember, we need slope. We need point slope form, which looks like y minus y1 equals mx minus x1. And then we need, I can write it here, m equals y2 minus y1 over x2 minus x1. And then we need standard form, which looks like ax plus by equals c. Anybody who tells you there's not a bunch of memorization in math lies to you. There's all these different equations that you can look them up places, but it's much more helpful if you have them memorized. You can go through the problems a lot quicker when you do have them memorized. So we need to find slope using this formula, find point slope form using that formula, and finally change it to standard form, which looks like that one. So we've got, erase some of this stuff. We've got x, y, 0.1, 0.2. So slope is y2 minus y1 over x2 minus x1. Minus a negative is really plus a positive. The signs are different. We have to subtract, and simplify. Positive 2. So we have our slope. Our slope is 2. Now, we need to write this equation in point-slope form. So using our slope, using one of our points, which I don't need this anymore, so both points are kind of ugly, so it really doesn't matter which one I use, so I'm going to pick that one, just because. No other reason. It doesn't look easier. It's just there. So we're going to take y minus y1 equals mx minus x1. That's point slope form. So y minus the y value equals m slope, x minus the x value. Now, one thing I don't know if you remember is this minus a negative is really a plus, or that trick we talked about how in point slope form is always the opposite side of what this is. So this -1 changes this into a +1. We talked about that when we did the lesson on point slope form back in 5.3, the last lesson. So now we have point slope form. Boom. Now we're going to take this and change it into standard form. So I'm going to get rid of my parentheses by distributing. I'll draw my rainbows underneath. I get 2x minus 6 equals y plus 1. I need to get my x's over here. I need to get my x's and y's on the left-hand side, so I'm going to minus 2x to get rid of the plus 2x. Minus 2x. That gives me a negative 2x plus a y plus a 1 equals, these are gone, a negative 6. And then we have to get rid of everything that's not an x and a y from the left-hand side. So this guy has got to go. So we're going to subtract 1 here, cancels, subtract 1 there. We get negative 2x plus y equals negative 7. That is standard form, and we done. So that is, that's one problem right there. Find the slope, point slope form, change it to standard form. It's a lot of work. But the better you know your formulas, maybe you have yourself a little note card. You have your different formulas written down on, and every single time you do a lesson or you do a problem, you write down the next formula. So far, the formulas you should have memorized. You should have slope. Actually, here, let me save some space since I already have them over here. You should have slope memorized or written down someplace you can look at very quickly. There. You should have slope. You should have point slope form. You should have standard form. The only other one you probably need to know right now is slope intercept form, which is the y equals mx plus b. Those 4 are vital for this chapter. And not just this chapter. Later on in other chapters, they're going to come up again. So maybe make yourself a little note card. You can refer to it at any time, but you got to know how to do them. Okay? Moving on to the lesson. Example 3. Now we're going to write an equation of a line. So it says write equations of the horizontal and vertical lines that pass through the given points. So this is actually 2 separate problems here. So let's look at letter A. Now, on your note sheet, you don't have a piece of graph paper, little graph space. I do here, but let's see here. So this point A. Point A is the point 2, 1, right there. Now it says it wants the equation of the horizontal line and vertical line. So this would be the horizontal line going through that point. This would be the vertical line. Let me see if I can change them a little bit. Make them a little bit bigger. Make them a little bit bluer. How about greener? Oh, yeah. This guy, we'll make him a bit bigger. Too big? Nah, that's good. And we'll make him pinker. Pink's hard to see. Red? Red works. So we want the horizontal and the vertical line passing through that point. Alright. So, what is the equation of the horizontal line? Well, this line right here, well, we can do this a few different ways. We can do this using point slope form, we can do this using slope intercept form, and then just simplify it down to whatever equation we get. How about we do this using slope intercept form? That's my favorite form. I think that one's the easiest. So to do slope intercept form, we need 2 things. We need the slope, and we need the y-intercept. What is the slope of a perfectly flat line? 0. Slope is 0. What is the y-intercept of this line? Where does it cross the y-axis? At 1. So now we can write down the equation. It was y equals mx plus b. So y equals slope intercept. And just to pretty this up, we never write down 0x. If there's no x's, if there's 0 x's, we just don't write it in there. So that equation, 0x plus b, actually just simplifies down to just too far. Just y equals 1. We don't have to write the 0x. So the equation of this line is y equals 1. It's every point on the grid, on the coordinate grid, where the y value is 1. The y value is 1 there. This has a y value of 1. That has a y value of 1. And there, and there. Every single point, even in between, there's 0.5, 1. Negative 0.5, 1. Every single point on this line has a y value of 1. Okay, so we did the equation of this horizontal line. Let's do the vertical line. All right. Now, this one gets a little bit funkier because in slope-intercept form, we do not have a slope. The slope is literally undefined because it has this straight up and down line. So slope-intercept form doesn't quite work for us here. But we can use this idea that we did for the y value. I mean, every single point on this line, what's common about it? Well, they all have an x value of 2. From here, I go over 2. If I was getting to this point here, I'd go over 2, up that many. If I was going down here, I'd go over 2, down that many. They all have an x value of 2. Now I want you to notice something here. X value, y value. X equals 2, y equals 1. Do you see how the x value and the y value are kind of part of their equations? It's a little, I wouldn't call it a shortcut. It's something you can use to double check your math later. Let's check this one here, letter B. 3, 7. So go over 3, up 7. 1, 2, 3, 4, 5. See, it doesn't even fit on here. 6, 7 is going to be up there someplace. So we'll use our imaginations a little bit. So the horizontal line here, the horizontal line is where the y values are 7. That's the horizontal line. The vertical line is where the x values are 3. So the x values are 3, the y values are 7. That's the equation of the vertical line, and that's the horizontal line going through that point 3, 7. I'd like you to try letter C. Here's letter C. It says write an equation of the horizontal and vertical lines going through the point -1, 4. Pause the video, do it on your own. When you're ready to continue, hit play, and go through it together. Okay, so let's see how you did. So 0.14. So first off, here, I'm even going to get rid of this guy because you don't have him. Let's see if I can do without it. So honestly, I would still make a little grid. I would still go like this, someplace on my paper, on scrap paper. And -1, 4 would be like over here someplace. So the do the horizontal. The horizontal line going through here. It'd be better if I actually went through the point. The horizontal line, all of the y values are equal to 4 because I'd have to go up 4, up 4, up 4, up 4. So the y values are 4. The vertical line, all of the x values go over -1, over -1, over -1. They all go through -1. And that's all there is to it. The part that tricks up some people is that the horizontal line, which we think is normally in the x direction, is the equation y equals 4. And the vertical line, which we normally associate vertical with y values, but the vertical line is x equals -1. That's what tricks up some people. But as long as you remember, okay, all of these points have a y value of 4, y equals 4. All these points have an x value of 7, x value of -1, x equals -1. It'll make more sense to you. Alright, last type of example, and these are, unfortunately, sometimes kind of hard. So it says here, find the missing coefficient in the equation of the line that passes through the given point. So there, in example A, I have this equation. ax plus 4y equals 2. Now, this should recognize as standard form. Standard form is ax plus by equals c. But here, they're giving us the b, they're giving us the c, but they do not give us the a. And we need to find out what that a is. The way we're going to do that is we have to use this point. Now, if you look at the equation here, we have 1, 2, 3 letters, 3 variables. You cannot solve an equation if you have 3 variables. You can only solve an equation with 1 variable. So what we're going to do is actually something we've done before, and it might be ringing a bell, is we're going to take the x value, plug it in for x. The y value, plug it in for y. And we're only going to have 1 variable left over. Then we solve for that 1 variable, figure out what it is, and then rewrite our equation. So let's do that. So we're going to have ax plus by equals c. Oopsie, why did I put c to 2? So we plugged in the x value, we plugged in the y value, all the other numbers stay the same. Now look at this. We have an equation with 1 variable. Now, the first thing I want to do is, this looks a little ugly. Let's just pretty this up a little bit. So when you have a times 3, we normally write that as just 3a. That still says 3 times a, just like that. 4 times negative 1 is a negative 4 equals 2. This looks a lot prettier. So now we just solve for a. We do those same 5 steps. There are no parentheses. There are no like terms. I do not have the same variable on both sides. Get rid of the add and subtract. So I'm going to get rid of this minus 4 by adding 4. Get rid of multiplies and divides. The way I get rid of this times by 3 is I divide by 3. And a equals 2. So now I could rewrite this equation with 2 in for my a. So I write 2 instead of a, 2x plus 4y equals 2. That's my equation in standard form. I found the missing coefficient. A was equal to 2. So I plugged in my x and y values from the point they gave me into the equation. That left me with 1 variable. I simplified a little bit and then just solved for that variable, got it by itself, and then plugged in our missing coefficient back into the equation, and we were done. Let's do letter B. Same deal. I'm going to plug in x and y for x and y. So this is going to be negative 5 times negative 4 plus b times 7 equals negative 1. Let's simplify this. A negative 5 times negative 4 is 20, plus 7 times b is 7b. Alright, we've got ourselves an equation with 1 variable, which is vitally important. 1 variable. Now we can solve. So we do not have any parentheses. We do not have like terms to combine. We do not have the same variable on both sides. We do have additions and subtractions. We can get rid of this other term that's being added to 7b. So we subtract 20. Subtract 20. That gives us 7b equals negative 21. Divide by 7 to get rid of the times. Divide by 7, and we get b equals a negative 3. So we know this b value is actually negative 3. So now we can just plug it back in. So we have a negative 5x minus 3y equals negative 1. That is our equation. So that's actually not so bad. Not as bad as I remember. That's actually a little bit easier, in my opinion, than what we were doing with the points up here and changing, oh, not this one, like these, trying to change this into standard form, I actually think this was much harder to do than here. Plug in your points, solve the equation. Okay, so I have one last problem for you to try, letter C here. And so it's the same deal. You're going to try to find out what that missing coefficient is. What is the A? So plug in your X and your Y. Go ahead and do the problem. Pause the video. When you're ready to continue, hit play, and we'll go through it together. Okay, let's see. Red's a little hard to see. We haven't done black. Let's do black. So you got A, the X value, minus 6 times the Y value equals 20. Simplify, pretty this up a little bit. We get a negative 8A minus 12 equals 20. No parentheses, no like terms, no variables on both sides. Get rid of the add and subtract. So we're going to add 12. Negative 8A equals 32. The way we get rid of a times by negative 8 is we divide by negative 8. Both the negatives and the 8 cancels. A equals a negative 4. So now we plug that back in. We get a negative 4x minus 6y equals 20. That is our equation in standard form. And we're done. The last thing we're going to do is we got just a couple more questions from the textbook. They come from page 312, numbers 3 through 6. Go ahead, pause the video, do those problems on your own. When you're ready to continue or you get stuck, you need some help, hit play and we'll work through it together. Okay, so number 3 says we want the horizontal and vertical lines passing through that point. I remember x equals negative 8, y equals negative 9. This is the vertical line, this is the horizontal line. So if you think about it, this point, negative 8, negative 9 is down here someplace. You'd have to go over negative 8. All of these points here have an x value of negative 8. That's the vertical line. And you'd go down 9. All of these points here, these are the horizontal lines. All these points have a y value of negative 9. Done. Number 4, let's see, the x, y, so the vertical line, the x values are 13, the horizontal line, the y values are negative 5, for the same reasons we did there. Number 5, find the missing coefficient, so it gives us the same thing we just did a second ago, so let's see, negative 4, my x value, plus b times my y value equals 7. Simplify, that's a positive 4, 1b equals 7. Solves, minus 4, b equals, that's a 4. That's an ugly 4, but it's a 4. 3, and if you have it as 1b, fine. Divide by 1, you're still going to get b equals 3. And then as standard form, that would be negative 4x plus 3y equals 7. And number 6, same dealio, ax plus, I guess I don't need the parentheses there, it's not multiplied by anything, y equals negative 3. Simplify, so this becomes 2a plus 11 equals negative 3. Solve, no parentheses, no exponents, no multiply, or no combining like terms. Get rid of the adds and subtracts, so we subtract 11, giving us 2a equals a negative 14. And then we divide by 2 to get rid of a times by 2, and a equals negative 7. So as standard form, that becomes a negative 7x plus y equals negative 3. And there we go. So the last thing we have for you is our summary. How do you write equations in standard form? So you can think back to any of the examples we did. Try to write yourself a summary. How do you write equations in standard form? So hopefully what you said is you need to have the equation in look like ax plus by equals c. And if you don't have it as ax plus by equals c, it's not standard form. Okay. The way we did it in our examples earlier is we wrote it as point slope form first, then changed it into standard form. So we can write that. How do I write the equation of the line in point slope form first, then change it to standard form. And for homework, again, looks like a lot of problems, but it's just like there's like 3 there, 3 there, 3 there, 3 there, 3 there. So it's just a couple here and there. Some of the questions are kind of easy, 1 or 2 of them are a little bit harder. But that's the homework, and this has been lesson 5.4. Thank you for watching.